for liquid at rest, the pressure at any depth will act equally in all directions. We have to prove this statement. Let me define you how to prove. Suppose cross section at this point, having area A on which a force is acting normally along this direction, F. Harsh, any doubt?
No, sir. No, sir.
So for this strip, let me define its component. Let's say this area is A on which a force is acting normally. So if you break its component, one of the component is along this direction and the other along this direction. Let's say inclination of this red strip with horizontal is theta. So the component adjacent to this theta, this part, and the component perpendicular to this theta, this part, according to this A, it will become A cos theta and it will become A sin theta.
A sin theta.
Is it clear?
Yes, sir.
Similarly, let me define the component of force. We have this strip on which a force is acting along this direction, F. So draw a vertical line and a horizontal line. So if this is theta, this particular is theta, so this will be 90 minus theta and this will become theta. So this force will have a component adjacent to this theta as F cos theta and none other along this direction, it will be F sin theta.
F sin theta.
Now, let's say this is surface first, this is surface second, and this is surface third, for which we have to calculate pressure. So first, for surface 1, pressure is force divided by area of cross section. Force is F and area of cross section is A. Let's say this is equation first. Similarly, for surface 2, pressure is force divided by area of cross section.
Yes.
For surface 2, which is at this bottom part, force is F cos theta.
Yes.
And area of cross section is also A cos theta.
A cos theta.
So cos theta and cos theta will cancel out. So
Yeah.
we are left with
F by
A.
Equation 2.
Let's say surface third, pressure third is equals to force. So for third part, we have force F sin theta,
yeah,
and area of cross section sin theta.
A sin theta, sin theta, cancel out.
So you're left with F by A only. So this is equation third.
Yes,
so
sir.
just compare equation first, second, and third. What you can conclude?
They are equal.
Oh, good. So pressure along this direction, P1, along this direction, P2, along this direction, P3. So you can say at same depth, it will act equally in all directions.
Oh, okay, sir.
So from equation first, second, and third, we can say P1, P2, P3 all are equal. Just write it down.
Okay.
In which chapter you are in school, Harsh?
So same chapter, like mechanical property of fluids.
In which topic?
Sir, viscosity.
Okay, okay.
Like we skipped the some part in the middle, and she started viscosity from the end, and then she will do this.
Okay, okay.
So done.
Okay. We may define the other statement related to this Pascal's law. It state for incompressible liquid enclosed in a vessel, the pressure exerted at any one end get transmitted equally in all direction without getting diminished. Suppose you have a vessel and there is a piston at this point, another at this point, another at this point, so if liquid is incompressible and enclosed in this vessel, so if a pressure exerted at any one end, let's say at this end, P1 is acting. So P2 will act at this point and P3 at this point. So according to this statement, if fluid is incompressible and enclosed vessel, P1, P2, and P3 must be equal to one another. Is it clear?
Yes, sir.
Okay. Just write it down. Let me define your application of this.
Okay, sir. None, sir.
Okay. Hydraulic lift, which is based on Pascal's law. There is an arrangement like this, in which liquid is filled, which is incompressible, enclosed in this particular tank like this. There is a piston at this point, another one at this point, having different area. Area of this strip is A1, area of this strip is A2. Let's say this is end first and this is end second. So if a force is exerted at this point, F1, it will exert a pressure P1 equals to force divided by area of cross section. Let's say this is equation first. So according to Pascal's law, it states a pressure exerted at any one end, so it will generate same amount of pressure at the other end. So pressure at point 2 will be F2 divided by area of cross section. Let's say this is equation 2. Now, using Pascal's law, you will say from equation first and second, and using Pascal's law, we can say P1 must equals to P2. On putting the value of P1, P2 in terms of force and area, we may write F1 divided by A1
A1 is
equals
equal
to
to F2
F2
divided
divided.
by A2.
Okay. Now, using this instrument, you will be capable of generating large amount of pressure by applying very small effort on it. Let me define using question. Just write it down.
Answer.
If the ratio of radii of piston and hydraulic lift is 1:3, a force of 20 Newton is exerted at smaller end. Find force on larger end. Use the above formula, write A in terms of pi r square, put their values and try to find. Any doubt?
Yes, sir. Sir,
Yes.
like, can you solve this? Like, I'm confused, like kind of confused.
Just see, we have F1 as 20 Newton. Okay.
Yeah,
And the ratio of the radius is R1 divided by R2 equals to 1 by 3.
1/3, yes.
And we have to calculate F2. Okay. Now just using above formula, we may write F1 divided by A1 equals to F2 divided by A2.
So
Move this
instead of
A2.
instead of A2 F dot pi r, like instead of area F dot pi r square, right?
Yeah.
Okay.
So F equals to F1 multiplied by A2 divided by A1.
Yeah.
Or further, area is pi r square divided by pi r square.
Yes.
So pi and pi cancel out. So you're left with R2 divided by R1 whole square. So
3 by
F1
1
is
square.
F1 is 20.
20.
R2 divided by R1 is
3 by
3
1
divided by 1 whole
whole
square.
square.
So it will become 20. Square root of 3 is 9.
9.
So it will give you 180 Newton as F2.
180.
Okay.
Okay.
Now just compare these two forces. Initially, we have just applied 20 Newton. And how
Yeah.
much we are getting?
180.
So you'll say, by exerting very small amount of effort, we can generate enormous amount of force to uplift very heavy object easily.
Okay, sir. Sir, I did till the this part, like F2 is equal to F1 by A2 is equal to, I wrote that, but then I don't know, I got some calculation errors. That's why I asked you.
Okay, okay, no problem. Done?
So one. Done, sir.
Now, there will be some theoretical questions related to this concept, Pascal's law. First is, suppose the average surface area of human is 1.5 meters squared. Find net force due to atmospheric pressure So we have to calculate net force due to atmospheric pressure on human body. Okay. Now, in last class, I defined you the value of atmospheric pressure. It was P equals to 1.013 into 10 to the power 5 Pascal. We may write 1 into 10 to the power 5. Okay.
Yes, sir.
Area of cross section for normal human being is 1.5 meters.
1.5 meters square.
So force will be equals to pressure into area. Pressure is 1 into 10 to the power 5. Area of cross section is 1.5. So on multiplying, you will get 1.5 into 10 to the power 5 Newton, which is in terms of mass. If you divide this expression by gravity, you will get, it will be about carrying a load of 1.5 into 10 to the power 4 kg or just 15,000 kg. Is it possible to hold this much amount of mass on our body?
No, sir, it's not possible.
We can't. So using this concept, we have calculated atmospheric pressure exert this enormous amount of force on our body, and we simply feel nothing. What is the mechanism behind it?
Okay, sir.
Let me define you. Just this is the layer of our skin on which there are some pores, and there is a layer of fat storing tissue just behind it, which is called adipose tissue.
Adipose tissue is skin's tissue,
which may have some bubble in which air from outside may get filled, and it may exert some pressure towards outside. So air from outside get filled into it, and they will exert some pressure towards this direction. Also, there will be blood capillary flowing across it. So there will be blood pressure towards this direction. So net pressure from inner side towards outer side will be due to blood pressure and also due to air filled in bubble of fat must compensate the action of atmospheric pressure. As a result, net effect of these two get cancelled out and we feel nothing.
Nothing.
Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Okay. Now there will be some other question. What will be pressure on our different body part in lying position and in vertical position? Suppose there is individual which is lying down on surface. So if you have to calculate pressure on its head and pressure on its toe, will these two pressure will be equal?
Yes, because he's lying down. Or
So
no.
these 2 points are at same horizontal level. Okay.
Yes, sir.
So pressure at head and pressure at toe and this part will be equal to each other.
It's equal.
But
Okay.
in vertical position, let's
It will be
say
different.
this part.
Yeah.
So if you have to calculate pressure at head and pressure at toe or feet, will they be equal or different?
It will be different, sir. He's standing.
Why?
So because his feet is exerting some pressure.
No.
Like,
let's say if you have to calculate amount of force on head, so it will be due to atmospheric pressure or air just above it.
Yeah.
Just P naught and nothing more. But
yeah.
if you have to calculate pressure at point 2, so
His mass. Yeah.
One due to air, atmospheric pressure, and the second due to blood capillary, which is placed over whole part. Okay, I'm not considering the pressure just below the surface of feet. Okay, I'm just calculating at any point on toe. Okay, so you will say there will be blood capillary connected all through body and which must be at some vertical column and which must be exerting pressure on that surface. So next will be pressure due to blood column that will be exerting some pressure at that point. Now just compare these two terms. You will say pressure at point 2 is greater than pressure at point head and vertical position.
Yeah.
Is it clear?
Yeah.
Okay, just write it down.
Done, sir.
Now next, there will be some condition of
Sir?
accelerating liquid. Yes.
So they can ask this, like, is there more pressure on this side or that side? They can ask this,
Yeah.
right?
Yeah.
Oh.
Next is pressure due to accelerating liquid. Suppose you have a vessel in which level of liquid is at this point. Let's say this is point A and this is point B. Now, this particular system is being accelerated towards right by some acceleration A. Will there be any change in level of liquid?
Yes, sir. While accelerating, P will have more like higher concentration of liquid.
Towards which side? Left or
Towards
right?
B, towards right, sir. We're moving like this, right?
Towards A or B?
Towards B.
Towards B. This particular system is accelerating towards right. Okay.
Yeah.
So if you accelerate towards right, it will tend to go towards left due to
Tend
pseudo
to go
force. Towards left due to pseudo force.
towards A, it will go.
Just place a pen on a paper like this.
Yeah. Yeah.
And just try to accelerate this particular system forward direction. Towards which direction this object will go?
Backward.
Towards good. So it means object will accelerate opposite to the acceleration of system. Okay.
Okay, sir.
So while accelerating this particular system towards right, there will be acceleration of liquid towards left. So
Left.
level of liquid make it change like this.
Towards left, yeah.
So just draw a horizontal line. Let's say this particular angle is theta. Length from this point to this point is L. And height from this point to this point is H. Let's say this is point A. Okay. Written.
So Done, sir.
Now, if you find pressure due to this vertical column at point A, so pressure at point A due to vertical column is rho g h.
H.
But if I suppose to calculate using this acceleration towards right, this pressure will be also due to acceleration towards right, density of liquid,
Yeah.
acceleration towards horizontal direction, which is A, and the column of liquid, which is an horizontal position, which we have L.
L.
So these two pressure will be equal to each other. We are just calculating in two different sense and nothing more.
Yes. Yeah.
So just compare these two terms. Rho A L equals to rho G H. Rho and rho gets cancelled out. So A will equals to G H divided by
H.
L.
L.
H is perpendicular and L is base. So
L is
perpendicular
base.
by base is tan theta. So
Tan
we may
theta.
write G tan theta. So you'll be asked, depending upon change in level, what will be the acceleration of this particular system? So you will say A will be nothing but G tan theta.
G tan
Okay.
theta. Okay.
Okay.
Yes, sir.
Just
Done, sir.
okay. Next is U-shaped tube or U-tube problem. Suppose initially we have a U-shaped tube like this, in which water is filled up to this level. So the level of liquid in both sides will be at same horizontal level, so that they will exert pressure or same pressure at bottom. Okay. Now, if you fill any other liquid to any one of the arm, let's say level of this liquid may get decreased to this point, and consequently level of liquid from the other side may get
Will
increased
increase.
to this point.
Yeah.
So level of liquid in this side will be at this point. Let's say this is row 1 and this is row 2. Height of column of this particular liquid is H2. So
H2.
just draw a horizontal line at the lowest interface of this particular segment at this point. Let's say this is point A and this is point B.
B.
So it says net pressure at same horizontal liquid or at same horizontal level for same liquid will be equal on either side of the arm. So according to Pascal's law, we can say at same horizontal level, pressure will be same on either side of this particular tube. So pressure at point A must equals to pressure at point B.
Pressure at B. Yeah.
So if you have to calculate net pressure at point A, so you will say there will be pressure due to air plus due to this column of liquid rho g h2.
H rho
And
2.
similarly, towards B, there will be pressure due to atmosphere plus pressure due to this column of liquid having height h1 rho g
G
h1.
H1.
Is it clear?
Yes, sir.
Okay, just write it down. Using the numerical value, try to find the value of rho 2.
Okay, sir. Harsh, any doubt? No, sir.
Let me solve. Hirsch,
Yes, sir. Yes, sir.
P0 and P0 will cancel out from either side.
Yeah.
We have to calculate rho 2. So we may write rho 2 equals to rho 1
Rho 1
GH1
GH1
divided by
divided by GH2.
G and G will cancel out.
Yeah.
The value of rho 1 is 10 to the power 3.
Yeah.
And H1 is
16
centimeter.
Yeah, 16 centimeter.
Divide by H2, which is 20 centimeter.
20 centimeter. Yeah.
So if you have to convert into meter, just multiply by 10 to the power -2 in
Minus
both
2.
numerator and denominator. So this term and this term will cancel out.
Cancel out. Yeah.
4 into 4 and 4 into 5.
Into 5.
So 4 divided by 5 will be 0.8 multiplied by 1000. So it will be 800 kg per meter cube.
Oh. Yes, sir. Same answer. I got the same answer.
Good. Okay. This is all about Pascal's law and pressure. Next is Archimedes principle. Harsh, any doubt?
No, sir.
Okay. Suppose you have a vessel and there is opening at this point and another vessel is kept at this point. Now there is liquid at its corner in this vessel like this. Now suppose another object this is the first case and this is the second case. In the second part, I have just inserted a body into it. So will there be any change in level of liquid in this segment on inserting this object into it?
Change in the
Level of liquid?
change in level of liquid. Yes,
Let's say this is volume immersed and this is volume outside. So you will say, since initially the level of liquid is up to the edge of this particular opening, so on inserting this object, it will displace equal amount of liquid on how much volume of this object is inside liquid. So it will displace equal volume of liquid towards it. So this will be termed as displaced liquid, and its volume will be equals to just VI, how much volume of object is inside or immersed in this liquid. Okay.
Yeah.
Now, initially, suppose this object was in air. So it must be experiencing some downward force due to gravity. So force or weight will be mass times gravity.
Yeah.
If you convert mass in terms of density, it will be rho into volume into
Volume
gravity.
into gravity.
Now, on inserting this object into this liquid, it will experience some lesser weight due to a force that is called Baryon force
Burn
acting
force.
upward direction.
Upward, yeah.
Okay. So according to Archimedes Principle state, when a body is immersed in a particular liquid, partially or completely, it experiences an upthrust called Baryon force, which is equals to weight of liquid displaced by that particular object. When a body is immersed in liquid, partially
Or fully.
or completely, it experiences an upthrust called Baryon force, which is equal to weight of liquid displaced by the body. Harsh, is it clear?
Yes, sir.
So using this, if you have to calculate Baryon force, so Baryon force is equals to weight of liquid displaced by the body. Weight is equals to density of liquid into volume of liquid displaced, that is VI times gravity.
Gravity.
So this will be expression of calculating Baryon force. Okay.
Okay, sir. Yeah.
Just write it down.
Done, sir.
Okay, any doubt?
No, sir. Okay.
Okay, just keep this part for today's class. In next class, I will continue it. Okay?
Okay, sir. Thank you, sir.
Thank you.